Somebody has problem. Homework will do next week. Next week. So next week we are going to have a homework. Okay, we talk about 3D. After calibration, we can talk about 3D. So So 3D getting important, especially 3D sensor, because right now we have a self-driving car, or we have a robot. I do robot. Somebody, Professor Zhuang in EE, they do the self-driving car, and Tesla do self-driving car. So we have Volvo have a self-driving car, and self-driving car we have a sensor. Sensor is a stereo camera. We have a camera, we have a LiDAR, right? LiDAR, or sometimes some different radar, something like that. So 3D become important. Here, okay, I talk a little bit about 3D. So why 3D camera is important? One example like this one. Suppose that actually, I'll talk about later about 3D principle. So suppose two cameras stereo. So any 3D, the purpose is this one. For what? For segmentation. You want to do segmentation, object segmentation. Suppose if I only take one photo here, actually this is me, and this okay, his name. Chengdu is an Indian. I forget his name. Okay, so two over here. So if one image, how can you separate this two person from one image? Is not easy. If you have a stereo, this I designed in year 1999. I designed this one, real time for DARPA, for American military. Okay. And this is the whole way of my company. So we have if we use the 3D. So one camera, your result will be this one. See? So both object, both person will overlap, so confuse. But if we have a 3D, it will become this one. So we call disparity image. So the object close to you, the other object far away from you. So we have depth. So we have depth. 3D, we have a depth information. So from depth information, we can separate this the front object and the far away object. So why we need to do the depth? Why we need to do the depth 3D? Because we can do a segmentation of depth. That's the purpose. So this is some example for the 3D. We see some example first. This is long time ago. Nokia want to do this one. This array. But this is the idea. So you can estimate the distance.
To build a 3D model. What you do with that model is up to you. Create a digital avatar or plug it into a 3D printer to create a personalized gift. Use your creativity along with a smart camera in your smartphone to make every occasion more memorable.
So they can print it out, right? So based on this is the idea. they say, okay, we have the cell phone, suppose cell phone, that's a long time ago. Suppose they have the 3D sensor there, and they can take a photo, right? And then based on software, they can reconstruct and print it out. Okay, and this is the other example for the Benz.
The new S-Class features road surface scan, a world first, which effectively turns ABC suspension into magic body control. At speeds of up to 130 kilometers per hour, road surface scan uses a stereo camera to monitor and analyze.
So they have a stereo camera here, and they try to scan the plane of road, 那个路面状况。So based on because road will sometimes will be like high and low, not stable. So based on this sensor,
the road ahead.
They
The
can
exact surface contour is then passed on to active body control. This improved active suspension system can almost entirely compensate for body movements resulting from uneven roads. Within split seconds, the suspension is prepped for the impending situation in order to significantly reduce any structural movement. The result is unprecedented driving comfort.
Okay. So based on the stereo camera, so they can know the uneven road, and then the feedback, the camera will feedback information to suspension 那个弹簧那边，所以它可以调整那个弹簧，然后让 very stable。OK， 这是实际的应用了啊，已经几年前了。So back to here. So what I try to let you know is that for the 3D sensor, usually have a four kind was assigned. It's just three kinds. Sorry, three kinds. One is stereo. There's two camera or more than two camera. They call stereo. So I teach you stereo. The second we call time of flight. Time of flight is like an ultrasound or like a laser. It's meaning you have a source and it project like a laser or ultrasound, and the flight time from hit the object and fly back, they have a sensor here. So the time suppose 10 milliseconds, flight time 10 milliseconds, and the other flight time is 20 milliseconds. And then that's meaning 20 milliseconds, the object is far away from you. The 10 milliseconds is close to you. So they, based on the flight time, they can try to reconstruct the 3D. The last one is similar to stereo. We call structural light, 结构光. And all three I did. 我这三个都有做过，都跟晶片公司有不同合作关系哈。然后这个我是跟德州仪器合作了，那这跟工业界，这个是也跟德州仪器合作，这合作5年。Okay, so we have stereo, structural light, and time of flight. Usually, if you do the programming, time of flight is easy because you just get a flight time information. You can do 3D reconstruction. Structural light is not easy. It's complicated. Stereo is a little bit complicated, but I will teach you stereo because almost structural light, almost all the information for 3D is related to the stereo. So I teach you this one. But for the cost, stereo is cheap, just 2 camera. Structural light is very expensive. Because they have a DOP sensor, so it's expensive. And time of flight is also cheap. Okay, so these three is cheap. Okay, and right now, after Connect, right now have a RealSense. Intel RealSense is very good. But I don't know why. Actually, Connect is good, but it's too big. And Microsoft sometimes they do the wrong decision. Like they don't do the Connect, and they do the HoloLens. And when I release the HoloLens, I feel, okay, that's probably a long-term plan. It's very, first of all, it's a $150,000,15万台币那个 too expensive. And for the VR, I say, VR, you need to wear that one. VR is still not popular because VR is inconvenience. So AR will become popular, but VR still have a long time to go. Okay. VR still should do that because a lot of things to do. But VR also need to design a light wearable thing mask 要想办法把这个戴的这个用方便一点啊。But for the accuracy, the structure dice accuracy is very high. Like we did is around 10 micrometer the structure light. And time of flight, I think time of flight is good for game. We do the human body gesture recognition. So time of flight is good for that one. It's between 1 to 5. So I feel time of flight is around human computer interaction around 1 to 5 meter is good for the time of flight. And stereo can do the near distance and longer distance, or even though 100 distance. Like when I designed the stereo in 1999, the military said, James, you need to design that one for, we can detect use the robot, and the robot eyes can detect the soldier or the military, the soldier about 100 meters outside. So I designed that one to detect the head. Okay. So there's three kinds. And right now we have RealSense. I like RealSense. RealSense is pretty good and cheap. Before it's only 6K, but right now they increase the price because cheaper increase the price. So almost the price is double. Right now it's about $12,000，在11200左右了，比较又贵了。The accuracy, so accuracy is around millimeter, 1 millimeter, 2 millimeter. This is distance. So longer, far away from you, the accuracy, depth resolution is become no good. Okay. And this is new. This is the other. I have a I have a cooperated with Intel, so I am familiar with the Intel product, and they have a L laser. D is depth. We have a D. This one is D. This is a laser. Sorry, depth. This D is here. So there's RealSense D. This is use stereo. RealSense 的那个 D 系列的是用那个 stereo 来做，2颗黑白摄影机，那再加上1颗那个彩色摄影机，它是这样子，所以它有几个镜头，有4个镜头 ，5 cameras. 2 is a black and white for stereo, and this one is for IR projector. 它用那个投那个，因为它有时候投一些点的辅助了。那 this is the RGB, but this is cheap. It's very good. And the other one is L515, but this no longer exists. Intel told me they don't want to sell it again. I don't know why. But this is actually this is similar to the iPhone. iPhone use the similar one, like a LiDAR. So this is a light. The lasers come up from here, and then this lens, and the lens will rotate very fast. So rotate this direction, or sometimes rotate both direction. So they can scan. They can have a 2D H3D scan. So this is L515, and I said iPhone 12 or 13 has something the same as this one. Okay. And this is LiDAR, 2D LiDAR. 2D LiDAR right now is not cheap, not expensive. It's around here 2.5 sorry $24,000 24000 okay. So other is just that you know they have three kind of sensors usually. I don't one by one, sorry. So this for gesture. So the point 3D, if you do 3D, always have point cloud. 那个点云图啦，所以 point cloud is one kind of technology. It's a field you can do the research on point cloud. 这 point cloud 实际上是一门学问啦，他们也是一个领域可以做 deep learning 的gesture recognition. 那这是 time of flight， 这我就先跳过去了。time of flight here, right? Page 18. You can this one you can project this one. Time of here, you can project the laser and doing the flight time. 哇，时间到了。这边好像比较没什么这个是我 this is we cooperate with the TI. This is they give us the IC and we try to do some firmware. 所以他做，那我们有做得很好，因为你看这个指头变多1倍嘛这是我们那时候做的，就 time fly， 就是我们跟 TI 美国这些大公司有时候会找我们来做一些开发新产品所以我们很乐意当白老鼠但是有时候他们产品会失败像他们有时候他们叫 soft connect， 然后结果被 connect 打败掉了，你看这个我们没有做得很好，可能是我们没有做好了，他就被打败掉了OK， 那我这里要让你看是 structure light， this is structure light. I explain to you a little bit about structure light.
High-speed video recording systems allow us to observe the momentary of Earth phenomena in real world.
See, this is a slow motion.
Formation of human body is essential in athletics and
Slow motion.
Collision analysis
So in
commonly
slow motion, you can see a lot of detailed things.
To understand the deformation of shape in 3D, high-speed shape acquisition is required. Our system is composed of a high-speed camera and an off-the-shelf.
Okay. So what's the structure like? Is this one? This is camera. This is one camera. Some like in our lab, my lab, we do one camera DLP, we do two camera DLP, and one camera, and we try to reconstruct this one. And they use a DLP projector. This is very similar to your projector, but it's a digital. And you can assume this is the other camera. 在 DLP 里，你可以把这个假设是另外一个摄影机。那所谓另外一个摄影机是什么 ？You can find why I say this is the other. Assume this is the other camera, but it's a projector. No, because it has lens. 投影机有 lens, so it can calculate its focal length. 它有焦距 ，so you have a focal length. So you have one focal length for camera, one focal length for DLP. You can do 3D reconstruction. 你把这个当成另外一个 ，so you assume this is the other camera, so this is stereo. So you can do the 3D reconstruction.
DLP projector. Projector illuminates the scene, and the camera captures the image.
Okay. So this is DLP. 那个谁TI 发明这个，他有找我做一些东西啦做这个。This is a DLP. This have a mirror. 上面有那个镜片可以打镜片。那是它只有两个角度一跟零一跟零对，一就是往正，零就是偏掉这样。所以
We call this way of light modulation as temporal beveling.
它一光打出去它上面有100，假设它解析度是100万，它有100万颗镜片。那如果是一，它就把光给你看到；如果是零，它就把光就不让你看。所以那个机械系的李永春老师很厉害，他很聪明，他用 DLP 来打光照的 pattern 嘛，他用 DLP 的方式，他光学很强， 这我们机械系的李永春老师，我跟他合作了啊，他找我，他做得很好，他就是你如果是就是他用光照，就是因为你打出去，那只要光不出去就是黑的、啊，就看不到啊，所以他用这个做光照。那我大概让你看一下，那
The single image
DLP will project the pattern like a mask, the pattern, or this kind of pattern. It also can project the color.
by
打不
finding
同
the
光。
best match between stripes on the object and
So why this one? Because if it's plane, the light was straight light. 你打出去如果是条码的，它打条码。If this plane 是一个平面哈，就是如果是一个平面，那打出去是不是一条直线 ？If this is a curve， 那你打出去这个就不会一个平面，它就有那种不连续的状况，这种不连续状况。So according to the discontinuity, and they can do the reconstruction， 它有演算法。这样
now we show the estimated correspondence of the stripes.
But precision very high.
By triangulation between camera and projector, the recovered 3D shape of a static statue is rendered.
See, they can do
from
3D reconstruction.
This example shows the 3D acquisition of a moving hand.
So the precision can be
So we have
10
6,000 depth frames per
millimeter, 10
Now we show the effect from a side view.
micrometer, 10 μm 哦，我们做到10 μm 这样子，它可以做这些。
1,000 depth maps per second by sliding the window to 25 frames along time. Now we show the result of a
Because it's strong light, so you should close your eyes. And they can, after you reconstruct, you can do the 3D printer, print out the
In
object.
summary, we have presented
So this is we call structural light. Okay, so this is the other example. 我把这个弄完好了，然后我们再下课好了。This DLP. 然后给大家看一下。So they do the scan this one. 我再让你看一下。This DLP. 打那个条，它是打那个条码，要看条码。They can do 3D reconstruction. 啊，打那个一条条是条码。就出来，那这个可以 print out， 这个印出来啊。那我大概讲一下哈，这里有个 idea 还没实现呢，哈，就是说，因为 DLP 可以做小小的一个盒子，那时候我们有讨论到是说，假设你去 you go to Starbucks, you got a cup of coffee, and then they have this kind of a scanner, so your foot 你的脚，就 put inside the box. And use DLP because they have a high precision. They can reconstruct, they can measure your foot. And then based on your foot, you can transfer this 3D information to the internet, to the shoemate company. And you can order, you can on the internet choose what kind of shoe you want to have, a color, shape, model you have. And they can do that one. And probably tomorrow or 1 week later, you will shoot them just customize for you only and will send to you. 哦，我们那时候本来想这个 idea 就是以后就是用网络订购了，用这个来做，因为这个可以做到高精密度的啊。哦，那再 one more example， 因为这是高精密度的，那我们可以跟机械手背结合。那这是大的物体哦。那 point cloud has one advantage, you can do the stitching。那么 ICP 哈可以 point cloud 可以把整个重建嘛，所以你就拍不同角度，那把整个重建起来。啊，是做这个量测，因为这物体很大嘛，做量测。啊，这德国已经有这样在做了哈。这个是 GON， 这是德国的，他用2颗摄影机加结构光做出来。 这一台100万哦，100万以上。那现在价钱，我那时候去，我为什么做这个？是大概我忘记了7、8年前吧。那个德州仪器美国德州仪器邀请我去去展场参加，我们东西也在那边展了。我们那时候是坐自驾车跟美国德州仪器。哎，我看到这个，然后问他这个价钱多少，200万台币，占一个200万台币。我说哇，这个我可以做，不用那么贵，因为它是也是用德州仪器的 DLP， 啊，只是它不会做3D 重建啊，这是他们最早发展出来的，所以我就回来开始做2年多。2个硕士做，哎，做出来了，然后就进度慢慢改善这样子啊，就给公司去用这样子。好，来看一下。Okay, so we take right now is we take a break until 10 minutes later. We take a break 10 minutes and we'll talk about deep learning. And next week we'll give you the homework and then we'll continue talk about stereo. 好，我们休息一下，谢谢。